the last lesson of the year, Algebra 2. 10.5 is on hyperbolas. First of all, the review. No lines. Are any of these parabolas? I see a parabola on number 4. Were there any other parabolas?
7.
So 4, and sure enough, 7 is a parabola. How about any lines? No terms of degree 2, only degree 1. I don't see any of those. Next, let's go for the hyperbolas, positive x squared, negative x squared. So 6 is a hyperbola. Are there any other hyperbolas? Okay, so we have a hyperbola on number 1 also. Are the rest ellipses? Which one is not an ellipse of the remaining ones? Yeah, if you take a look at number 3, you see that it's a circle. So thank you. So are the other 2 ellipses?
No, 5 is a circle.
Careful, 5. Oh yeah, you're right. 5 is a circle also. Absolutely right. So circle. 3 was a circle. So only 1 ellipse. Any questions on the warm-up? Okay. So that's the new material, or rather that's a review of the old material. For the new material, we're going to look at the concept of a hyperbola. But before we look at the standard form for a hyperbola, let's make sure you really know the other standard forms. For example, do you know the standard form of a parabola? Now, it's got an h and a k. So with a parabola with a vertex at h comma k, since we have a test on this on block day, you know, in 72 hours, roughly, a little bit less than that, you're going to have to show me that you know all 4 standard forms: parabola, circle, ellipse, and hyperbola. So would you please, from memory, no notes on this, friends, from memory, what is the standard form of a parabola whose vertex is at h comma k with a stretch factor of a? Write it down from memory. See if you know this. After you're done with parabola, move next to circle, and then ellipse.
Would this be on the test, writing out the standard form without, like...
I'm not going to tell what's on the test, but you need to know the standard form for parabola, circle, ellipse, and hyperbola. So write them down. If you don't know these, then your prospects for getting an A on the test are dim. You actually need to know the standard forms. Whether we ask you to write the standard form or not, that I'm not going to tell you, but you need to know what they are. Now, if you get stuck, ask your fellow group member, maybe if you can't get parabola, move on to circle then. After circle, do ellipse. But go ahead and put them in the right-hand margin here. You need to know 4 standard forms. I'll give you a hint. All 4, well, the 3 that I'm asking you for have an H and a K. So think about where the H's and the K's go. Try this without notes. Try to get these from memory. This is what you need to know. This is what the Unit 10 test is about. Parabola, circle, ellipse, and hyperbola. Now for parabola, if you wrote y minus k equals a times x minus h squared, remember this is a good review for it. Only one of them is squared. The y term is not squared, I mean that's fine. Others of you might have written y equals a times x minus h squared plus k. I don't care whether you write it like this or like that. I think this first one's a little easier to remember because just like all the other ones, it's got both an x minus h and a y minus k. You can go either way. How about for a circle? What is the standard form of the conic to which we refer to as a circle? Volunteer for this one. Just a little hint. It's got a lowercase r in it. Got a lowercase r. All right. Well, Jack, do you want to give it a go?
No.
You want try it? I mean, it'll have an x minus h. So think circle. What happens to x minus h in a circle?
You know, I don't know.
It's the same thing as in a parabola. So it does have this in it, and it also has a lowercase r. So tell me what you think it is, starting with the part that I told you is there.
Let's go with x minus h squared.
Yeah.
And then something with an r.
Who can help Jack out? There's more to it. For a circle, there's more to it than this. Anna.
Plus y minus h squared.
Y minus k squared.
K, yeah, that's, and then that's equals r squared.
Equals
Yeah.
r squared. Jack, now does this ring a bell? Yeah. Oh, wonderful. Now, let's do the ellipse. Now the ellipse one is really similar to the circle standard form, except not only do you have x, y, h, k, you also have a and b. So rack your brains to try to see if you can remember the standard form of an ellipse. Go ahead and write it down if you haven't already. All right, I'll take a volunteer. Standard form of an ellipse. Well, you just turned in a homework assignment on it, so this should be relatively fresh in your mind. Oh, and why don't you give it a go?
I wasn't here on Thursday.
Did you watch the video?
Yes, I did. I do not remember.
But you just don't remember. Who can help us get started on this one? So what do you think? Sophia, go ahead.
I also wasn't here on Thursday.
Did you watch the video?
Yeah, but I don't remember.
Okay, so yeah, this is hugely important for this week's test. Jack,
I think I'm gonna know this one, Mr. Roy.
why don't you give it a go?
Let's go x minus h squared over a squared.
Sweet.
And then plus y minus k squared over b squared.
Equals, and it's not r squared, instead it's a number. It's just one number. It's the one number 1. Yeah, that's it. So, those are the 3 that we've learned so far. Yeah. Good. Parabola, circle, ellipse.
Yeah.
You need them all. Okay. And today we get the 4th one. It's actually the 4th and 5th. There's 2 types of hyperbolas. There's an x hyperbola and there's also a y hyperbola. And just so you know visually, in an x hyperbola, the branches open left and right. So you have a branch to the left and a branch to the right. Whereas in a y hyperbola, the branches open up and down. Bethany.
Will we go over like how a parabola opens up and down?
That'll be tomorrow on review day. We'll talk about that. But today's hyperbola day, we're going to look at both the x hyperbola and the y hyperbola. Now, here's the standard form. And this is going to be welcome news for Jack. And because it's really the same as the ellipse, except instead of a plus, it's a minus. I mean, think about it. With these review things that we've been doing every day, it's like if there's 2 quadratic terms, x squared and y squared, and they're both positive, it's an ellipse. With the hyperbola, one's positive, one's negative. So the standard form for a hyperbola is x minus h, quantity squared. You knew that was coming. You knew it was going to have an x minus h squared. All the other ones do, over a squared. But instead of a plus, it's a minus, which is what you would expect from a hyperbola. Y minus k squared over b squared equals 1. There it is. Standard form for an x hyperbola. The only difference between an x hyperbola and a y hyperbola is that the x and y are squared, so that the y squared is positive and the x squared is negative. So for a y hyperbola, we have y minus k squared over b squared minus, plus it should be a minus x minus h squared over a squared equals 1. notice that B always hangs out with K, A always hangs out with H. They're together, so that way you don't have to think about those ever being scrambled up. They're always paired up. So let's do an example. How do we get these hyperbolas? Well, question, Bethany,
Oh,
go
no,
ahead.
never mind.
So in this one, we can tell that the center of the hyperbola is at -2, 1 by harvesting the values of H and K from the equation. It's up here, yeah? So A is 3 and B is equal to 2. Just like with ellipses, you can squeeze the values of A and B right out of the equation. So let's center this at -2, 1. With a point at -2, 1. Now, if this were an ellipse, we would go right and left 3 units. Same thing with the hyperbola. From the center, let's go right 1, 2, 3, and left 1, 2, 3. And then back to the center. From there, we're going to go up 2 and down 2. Okay, so but instead of drawing an ellipse, we're going to draw a hyperbola. And to aid you in sketching the graph of a hyperbola, we need a dotted box. I'm going to put just draw a rectangle that goes through these 4 points. And so, yeah, if you just came in the door here, we're just looking at our last topic. It's a standard form for a hyperbola, just like an ellipse, but instead of a plus here, it's a minus.
Okay.
So that's the x hyperbola that we're working on now. Class, now that you have your dotted rectangle, it turns out that the diagonals of the dotted rectangle are the asymptotes of the hyperbola. So, yeah, all of you really should have your desk cleared except for this handout. Jack, would you clear your desk of everything except for this handout? Yeah, just all that stuff. There's a lot of other stuff there.
This is all math.
I know, just take it all off your desk, and except for today's notes, just the whole thing. Thank you, appreciate that. And Owen, also, would you just get all that stuff on? It just protects people from distraction. I know, yeah, so what we're doing, we're clearing our desk of everything except for today's notes. Now,
Wait, can I have this on my desk?
yeah, if you have any questions, you can see me. Well, I'm asking you to clear your desk. Now, if you want to have air molecules and photons on your desk, I mean, that's fine this time, just this time, okay? So now what I'd like you to do is go up 2 over 3. So we're going to draw diagonals and then extend the diagonals beyond the box until they go off the grid. And then extend the other diagonal beyond the rectangle. And that gives us the asymptotes. For an x hyperbola, the branches are going to open left and right. So honor the asymptotes. And what I mean by honor the asymptotes is that we get closer and closer, the graph gets closer and closer to the asymptotes instead of, I'll show you an example in blue of a branch that does not honor the asymptotes. You know, this blue branch, the blue graph is not getting closer and closer to the asymptotes, it's actually getting farther and farther away. So the red one is an example of a hyperbola that honors the asymptotes. Those of you who are wondering what's going on with the dotted box, it turns out that every hyperbola has a dotted box, even parent graph number 10. Parent graph number 10, y equals 1 over x, has a dotted box. Now, we hadn't drawn it in the past, but I want you to see where it is. It's just briefly, I'll come back to that, those of you who haven't finished taking notes on that, but 1 over x is a hyperbola that has a dotted box. It turns out that 1, -1, turns out that the dotted box for 1 over x is a 2 by 2 box, and actually it's those points are on the diagonals. So when you draw this, the dotted box is actually like a diamond. And when you, this is 1, -1 on both axes. And when you extend the axes, or rather extend the diagonals, and then draw the branches honoring the asymptotes, you get the y equals 1 over x parent graph. But in the past, when we've drawn this parent graph, we've never actually drawn the dotted box. Today I'm going to show it to you for the first time so you can see the connection between calling this graph a hyperbola and calling this graph a hyperbola. This graph, every hyperbola has a dotted box. So, let's do our first example of a y hyperbola. And again, I know it's a y hyperbola because the y squared term is positive. Here, the x squared term is negative. So let's go to this and try to figure out where the center is. So in this example, this is a y hyperbola. What are the coordinates of the center? Let's go with Amani. You said -1, 3, right? It's actually switched because the h is always linked with x. So watch out for that. It's actually 3, -1 is the center. Very common mistake to make. It's always this, the center is always at h, k, or the vertex, the center is at h, k. So in this case, 3, -1, let's plot that point. And what are the values of a and b? In this case, what is the value of a? Jonathan.
A is 1.
Nice work. A is 1 and b is equal to 4. So from the center, let's go right and left 1 unit. And from the center, let's go up 1, 2, 3, 4, and down 1, 2, 3, 4. Draw your dotted box and the diagonals extended to the end of the grid. Going up 4 over 1. So keep that slope. Here, this is up 4 over 1, up 4 over 1, down 4, left 1. Now, here's what not to do. Do not make it an x hyperbola. The answer is not this. X hyperbolas open right and left. This is not an x hyperbola. I can tell because the x squared portion is negative. Since the y squared portion is positive, it's going to be a y hyperbola, which means the branches are going to open up and down. Here's the branch that opens up, honor the asymptotes, and here's the branch that opens down. So instead of 2 branches that open left and right, it's 2 branches that open, one opens up, the other opens down. Any questions on the graph of this hyperbola? It's a little easier if the equation's already in standard form. What if the equation is not in standard form? Let's go to the back side here. So on the back side, just like with ellipses, in fact, this is probably going to seem a lot like the lesson on ellipses. We're going to simply we're going to use the commutative property of equality to collect the x terms together. Join me in writing 25x squared plus 100x minus 4y squared plus 8y equals 4. And now we're going to set up the boxes after we factor out 25 and the -4. So when you factor out the 25, what numbers are left in parentheses? I mean, it will be something x squared plus something x plus blank. We're also going to factor out a -4. But what number is going to go in this blank right here? Bethany, help me out. 4 is correct. So that tells us what the first green box will be. Now, when you factor out a -4, what do you recommend I write in parentheses for this one? All right, let's go to Mia. Well, let's factor a -4 out of this term and that term. When you factor a -4 out of -4y squared, what's left in parentheses?
Y squared plus 4 and 2.
Yeah, but since you're factoring out a -4, it's gonna have to be a -2y plus a blank for completing the square. So that's gonna be equal to 4 plus blank plus blank. Let's draw all 6 boxes for completing the square. 3 green boxes to complete the square in X. And then 3 orange boxes to complete the square in Y. So. Okay, so got 3 green, 3 orange. What's the triplet of numbers that populate the green boxes? Help me out with that one, please, Gerald.
4, 2, 4.
Thank you. And the triplet for the orange box is Mason.
-4.
Now, careful, the first one actually comes from the coefficient of the linear term. So the first, see, just like the first one over here was 4, we went 4, 2, 4. The first one here is -2, followed by what?
-1.
And,
No.
good job. Okay, so with the 4 here, that means I've got to complete the square with 4. Now, the equation's out balance. What number will balance it, Sophia? What number in this blank will balance the equation?
4.
No, because I didn't really add 4
Oh,
here.
100.
Yeah, I added 100 to the left, so I better add 100 to the right. So, good work with that. Now, to complete the square in Y, the third box is 1. What number will balance that change over here? Let's go with Alana. -4 is correct. Our next code is going to be F for factor. What is the factored form of this going to be? I need some help on this one. Please, Bethany.
25 in parentheses x plus 2 squared minus 4 with 1 in parentheses y minus 1 squared.
Equals,
100.
and this is 100. So, nice work on the factoring step. Let's get the code right down there. Now, what do you think the next code will be? What's the next
Did you
code?
get 10 for your?
Lauren.
You got the 10. I'll leave that quick. Now, when trying to answer the question, what's the next code? This is where it helps to actually know the standard form. Because if you know the standard form, you know you have a 100, but you're aiming for a 1. So what code will turn that 100 into the number 1? I mean, yeah. Yeah, you're right to divide by something. But we have to divide by 100 to turn this 100 into what appears in standard form. So, when you divide by 100, I mean, some of you actually go over 100, over 100, over 100, which is fine if you do that, that's great. When you do that in your head, is there anyone willing to do it in their head and tell me what this ends up being? Daniel, go ahead.
Which one?
So when you do what Lauren suggested, and that is divide all 3 of these terms by 100,
Oh,
this first term will end up being x plus 2 squared over what?
1/4.
So it'll be over 4. Keep going.
And then
Instead of saying and then, say either plus or minus.
minus.
Nice. Keep going.
-2.
Well, no, this is y minus 1 squared.
Yeah, divided by.
Just imagine there's a 100 down here,
Yeah,
and do a mental math problem of reducing the fraction
25.
4 100ths
25.
is over 25 equals what?
Just 0.
What's 100 divided by 100?
One.
It's 1. 100 minus 100, just for the record, is 0, but it's not subtract, it's divide. So, class, go ahead and finish it from here. Sketch the graph. Oh, by the way, is this an x hyperbola, branches opening left and right?
Or is it a y hyperbola, class? I mean, Andrew? Which is it, x or y?
Oh.
It's a
X.
Y.
It's a y, okay, raise your hand if you think this is an x hyperbola. Things you put your hands on. Raise your hand if you think it's a y hyperbola. Okay, thanks, you can put your hands down. Now, this is an x hyperbola, you can tell because the x squared term is positive. When the y squared term is positive, then it's a y hyperbola. So, center it at -2, 1, with a equals 2, b equals 5. See if you can sketch the graph of this x hyperbola.
So you said the x squared term is positive? That's
Yeah.
up?
Yeah,
So
and
what
the
if
y
it-
squared term is negative. When the x squared term is positive, it's an x hyperbola.
And if the y squared term is negative, then it's,
Well, yeah, in a hyperbola, the only time you have a hyperbola is when one's positive, the other's negative.
okay.
If they're both positive, it would be an ellipse.
Okay.
Okay, so, all right. And then, at this point, it's important to admit that you enjoy sketching graphs of hyperbolas.
I admit it.
Admit it. Okay, so it's an x hyperbola. So your branches, one branch opens left, the other branch, the other branch opens right, opens left, opens right. So the points here, vertices, if you will, are at 0, 1. Other vertex is at -4, 1. Not that you have to specify those points. Pause here. Does anyone have any questions on numbers 5? Okay, I think you can do number 6 on your own. So go through the routine and put it in standard form and then sketch it. Yeah, Gerald.
Why do we move 100x in the original simplified version of the original question?
Oh, well,
Like
before you complete the square, you have to collect all the x terms together
Mhm.
so we can complete the square in
Oh,
x.
I'm slow.
And then
Okay.
collect the y terms together.
Yeah.
Okay, all right? Good question.
I read the 4y wrong. I thought it was 4x squared.
Sure, that's fine. All right, so we're all doing number 6 by ourselves. Your last code should be a D4. If all goes well. Okay, when you're done with your standard form, look up here to see if you agree with my standard form. Okay. So, last one then, with the center at -2, 3, out of curiosity, raise your hand if you also had a center at -2, 3. So widespread agreement there, A is equal to 1. I have a B value of 2. So your dotted boxes up in here, just maintain the slope of up 2 over 1 as you extend this diagonal. Then -2 over 1. So since it is a y hyperbola, your branches one should open up and the other opens down. Make sure you honor the asymptotes. Any questions on number 6? Andrew?
Why is it a YS and Y?
Well, it's because the y term is positive.
Okay.
When the y term is positive, it's a y hyperbola. When the x term is positive, then it's an x hyperbola. Further questions? Yes, Gerald.
Wait, so like I set up my problem like the opposite way and I put the x's first.
Well,
So you can't
know
do
what though? The first term's got to be positive. The minus has got to go in the middle. So if you put the x term first, then you factored out a -4. So then yours was, if you did it correctly, then you had -x plus 2 squared plus y minus 3 squared over 4 equals 1. Is that what you ended up with?
I just didn't have a positive y minus 3, so that's just on me.
Yeah, so bottom line is that every time you look at standard form of a hyperbola, you notice that the minus sign is between the two terms. It doesn't matter whether it's an x hyperbola or a y hyperbola, the subtraction sign has to be in between. So notice that for the x hyperbola, x squared is positive, for the y squared, for the y hyperbola, y squared is positive. Further questions on this concluding example? Well, that concludes Algebra 2. Thank you for taking the course. You are dismissed for the summer. Bye now.